So here on number 4, exact same process. Except now we have years starting at 1970, so we'll start with 0 there. And of course it's talking about different stuff. It's talking about births to females over the age of 35 in some given state after 1970. So I'm going to have 0, 2, 4, 6, 8, 10 for my x's, counting all the way down to 16. And again, I'm going to put the x's in L1 and the births in L2. So now when I put this data in my calculator, I will again go under Stat, Edit. I'm going to hit Clear Enter to get. Okay, so now that I've got the data in my calculator from that table, let's read more details of the problem to see what I should do with it. I was being a little projective here because normally when we have data we are expected to get a model, so we need to put it into our calculator. But just like the last problem, it says use technology, also known as our calculator, to find the quartic function. So this time we'll use quartic. It's the best fit for this data. So what I'm going to do is hit the Stat key on my calculator. I'll go to Calc, and it told us to use quartic, so I'm going to choose Court Regression. Again, I always use Y-vars Y1 so that it sends it to the brain of my calculator. And the easiest way to do this, guys, you can look at the picture to make sure it did a good job or whatnot. You're welcome to write the function down like we've already discussed it on number 3. But the easiest way to do this is to hit vars, get that Y1 out of there, and just say Y1 of. It's asking us this time to predict what the birth rate is in 1990. So that's when X is equal to, let's see, 1990 minus 1970, that's 20. So when X is 20, find what is Y equal to. That's the goal of the problem. So when I have Y1 of, and I plug in 20, close parenthesis, it's giving me 107.14, repeating. Now on this particular problem, it's important to note, first of all, that this answer doesn't match exactly to any of these. So something I did just to see how much rounding error would affect this is I actually tried to calculate it several ways. By putting the 20 in this way, you get 107.14 repeating. The same thing happens on your picture. If I went to Zoom Stat, I get a nice picture, and of course I'll have to zoom out once. That's kind of standard when they're asking us to project things beyond the data that we've been given. So I'll say zoom out. Second calc. And when I put in my X equals 20 here, I'm getting the same answer. Again, by checking the table, I'll get the same answer also. Now, the interesting thing on this particular problem is that if you had chosen to write it out, I rounded to 4 decimal places. Write it out being from the main screen, but having some rounding happen. If you plug those X's in as 20 every time, you'd actually get a different number. So instead of getting the more accurate number from the technology, from the calculator of 107, you're actually getting something closer to 101. Remembering, of course, that these units are in thousands. The reason I point this out is because if you did it by hand, allowing some rounding error, you'd come up with C. My recommendation, however, is that you use your technology. Show me work anyway, because either way I would give you credit. But as far as when you're trying to determine the correct answer, use your technology to the fullest. In other words, don't be using rounding when you don't have to. I would choose D here because that's the closest that we have to the answer that we're given. Again, had you chosen even B, as long as you've got your work, I'll be able to understand that you were looking at it. I see that there's an X in every single term, so I'm going to pull that out first. let's see, that gives me x times x squared to get my first term back. X times, I need a 5 and an x to get that 5x squared back. And then an x times 6 to get my 6x back. So immediately I already have x equals 0 coming out of this. Now looking closer at the center stuff that's equal to 0, to factor that I've got, let's see, I use grouping method. You all can use any method that you'd like. In fact, remembering, of course, that to factor, you can use the quadratic formula, you can use completing the square, or you can use your calculator to find when this crosses the x-axis, since we're actually solving, not just factoring. But to try to follow the directions and do the actual factoring process, I'm going to work through the grouping process. So here I'm looking, let's see, there's a 1 in front of x squared, 1 times 6. I'm looking for two numbers that multiply to be 6 and that add to be 5. That looks like a 2 and a 3 to me. Once I've found those numbers, I split my center term. So I have x squared plus 2x plus 6x plus 6. And this is where the grouping begins, where I look in groupings of 2. So looking at the first two, I'll pull off an x plus 2. Then ignoring the first two and looking at the second two, I'll pull off a positive 6, x, oh, excuse me, do I have a mistake here? Oh, that's supposed to be a 3 right there. So that would actually be a 3 there. So that I'm getting an x plus 2. Good, because of course they have to match. So from this I'm going to get x plus 3, x plus 2 equals 0. So we're getting 3 answers. We have our original x equals 0. We have, let's see, x plus 3 equals 0, giving me x equals negative 3. And from the x plus 2 equals 0, we're getting an x equals negative 2. And again, you can check these answers by graphing your original function and seeing where it crosses the x-axis by finding the zeros on your picture. You can check every one of these answers. On the next one, it's actually really nice because they've already broken it up a lot. There's not a greatest common, well, actually there is a greatest common factor. We could pull out, it looks like a 3. Let's do that just to make it look easier. So if I pull 3 out of everything, what will I get here? I'll get 3x cubed minus 2 x squared minus just a plain x plus 2 equals 0. And actually that wasn't completely necessary, but it does follow with general procedure here of pulling out the greatest common factor. The only thing I need to be careful of is that I get the original back if I multiplied that 3 through, because it is easy to make some math mistakes, and I think that looks good. Now, by pulling that out, notice it's attached by multiply, so if I divide it on both sides by 3, see how it just goes away? So really what I'm looking at, because that gives me a 0 again over on the right, I'm really just looking at this new set of 4 terms on the left, since the 3 was kind of absorbed into the 0 when I divided. So now I can do grouping and look 2 by 2. Looking right here, I'm going to pull out, let's see, x squared times x minus 2. And then over here I'll pull out a negative 1 because of course I want the stuff in parentheses to match. So I was being careful here. I know that I want to have an x and a minus 2. That's why I chose negative 1. So here I've got x squared
Come on, Bella. Come on, Bella. Come here, Bella. Come on.
So here I've got x squared minus 1, x minus 2. And of course I can break that up more. Let me write it over here so that we have more room to write. X squared minus 1, remember that's the difference of perfect squares. So I can write that as an x plus 1 and as an x minus 1. And then the x minus 2 was already okay. So I'll just recopy that. So as we look at this, every time I have to stop, I have to actually, it's going to take me hours more to edit this video. I have to go in and cut out sounds.
I know, I can't do a thing about Belly sitting over there. She's on the lap. I can over there too.
Okay, so here I've got x equals negative 1, x equals a positive 1, x equals 2. Also, guys, remember in solving both of these, in addition to being able to look at the picture, which I always encourage, You also know that by looking at the degree on these polynomials, the degree on both is actually 3. You know that you're expecting up to 3 answers. So we're feeling pretty good about ourselves in getting 3. We know that that's the most we could have gotten. We have a really nice case here. They're actually giving us a hint to tell us which method to use, because the easy case is we only have one x. Whenever you only have a single x, really the easiest thing to do is to get the x by itself and to solve for it. So, to isolate my x to the fourth, I'm first going to add 343 to both sides. Again, we know this is the strategy because we only have a single x. Now, to clear off my 1/7, I have a fraction attached to my x to the fourth. When I flip a fraction and multiply, so in other words, by multiplying by 7/1 on both sides, that's the equivalent, remember, as dividing, because we know when you're dividing with fractions, you flip them and actually multiply. So I'm just going to write times 7/1 to clear that off. So now I have x to the fourth is equal to fourth power off of this by using the opposite of the fourth power, which is the fourth root. Remembering, of course, that when you're dealing with even things, not only do you have to be more careful and check your answers, but you also need to put a plus and minus in front of it to give options for both. So here I have x is equal to plus or minus. To put a fourth root in the calculator, you can either put the number to the power of 1/4, if you remember that a fourth root is the same as whatever it is you have to 1/4. Or you can hit 4 on your screen, math, and then choose number 5, which is an x in front of a radical or a root symbol. So I get the fourth root of 2,401, and that's a 7. So x is equal to plus or minus 7. Now again, we have to be more careful with these because of the fact that we had even things happening with powers. So I need to test both my positive and my negative 7 before I can move on from this. So what I'll do then is I'll put in 1/7 times, first I'll put in a negative 7 to the fourth power minus 343. That's working. And then second entry, it's very fast to put in the other one. I'll just go on to the negative and delete that off.